Greetings and welcome to Astrophotography Japan. I'm JP Astro Guy. This is my 10th episode. This evening I'll be sharing with you my equipment setup and how I plan to do some visual astronomy using a refractor telescope. I'll be using all of the equipment that you see here on the table, including this AM5 mount from ZWO, which I will configure in the Alt-az mode to track the stars in the sky, and I'll show you how I set that up. In addition, I recently purchased this Baader Morpheus eyepiece here, which I'm very interested in comparing to my current set of eyepieces, which are the Astronomics Paradigm eyepieces. And of course, this is the refractor telescope. It's the AD ED telescope from SVBony. And I'm also going to show and explain to you this contraption, which I assembled from bits and pieces. And it's specifically designed to hold the telescope in a position that's suitable for Alt-az and gives me very convenient access to all of my accessories. So, if that sounds of interest to you, please stick around. Let's dive in. Firstly, let's talk about the AM5 mount. As you can see here, it's currently in the equatorial configuration. It's inclined at about 33 degrees, which roughly corresponds to my latitude here in Yokohama, Japan. In addition, the declination and the right ascension are parked in the home position. So we're going to have to shift this into the Alt-az mode, and I'll show you how to do that. Using Alt-az for visual observations is much more convenient for a number of reasons that I'll demonstrate later. Now, the AM5 mount is mechanically constructed to adjust the altitude angle all the way from 0 degrees to 90 degrees. In the manual, this is referred to as the pitch angle. However, to cover this entire range, it was necessary to divide this into two gear pitch angle positions. The first covering 0 to 60 degrees for low latitude equatorial use, and the other covering 45 degrees to 90 degrees for equatorial mode use by astrophotographers living in higher latitudes. To use the AM5 mount in Alt-az mode, we essentially have to select the higher pitch angle position and dial the mount all the way up to 90 degrees. Now let me show you how to do that. Notice when you look closely at the side of the mount's base, there is an area on each side where you can see some recessed Allen screws. My mount is currently in the low latitude pitch angle position, which is the way it is shipped to us in the case. So to set up the Alt-az mode, I need to loosen these screws on both sides to shift the mount to the high latitude pitch angle position. First, adjust the angle so that you can see the screws easily centered in the middle of that hole. Then retighten these large wing nuts to hold the angle before you start to play with the Allen screws. You only need to loosen them, so about 1.5 turns should be sufficient. And before you loosen these wing nuts, put your hand underneath the AM5 mount to hold it, because when you do, this will become freely movable. Pull it all the way up to the top now, and you've shifted it into the high gear position, basically, the high latitude position. Now you're going to have to tighten up those Allen screws again, but you may have to dial this a little bit in order to bring them back into position so you can get access to them. But keep holding this as high as you can hold it up. Keep that angle as high as possible. And then tighten up both sides. And we now have it in that high latitude position. And you can tell because now you should be able to dial it all the way up to 90 degrees. And if you can do that, tighten your wing bolts, and now you're in that mechanically in the Alt-az configuration. Once you've completed that, there's one more step to do to get this fully in the Alt-Az mode. And that step involves software. You can see now if we were to put the telescope on this, it would be pointed straight up to the zenith, and that's not the home position in Alt-Az. So we need next to switch the software mode to Alt-Az by going into the AM5 application. And here's how you do that. First, you have to be sure that you hook up the hand controller, and of course provide power to the mount. So it's currently turned off. But before we turn it on, hold down the bottom button here on the hand controller. I think this is called the cancel button as it's written in the manual. And then turn on the mount. That second beep tells you that it's now engaged. And if you look closely at the status light, it's flashing between red and green, red and green, red and green. So now we can go into the AM5 application on your iPad or your iPhone. To do this, of course, you need to connect through Wi-Fi. Open the application and navigate to the setup screen by clicking on the middle icon shown in the bottom left corner. When you do that, you can see under Mount Mode that it should now say Alt-azimuth mode. Above that, we can see Home Position and a green button that says Go Home. After clicking that button and Start, the mount should now rotate the telescope Vixen clamp 90 degrees to a position parallel to the ground. This is the home position at altitude 0 degrees. When in the Alt-Az mode during operation, the status light on the AM5 mount will be colored green. Just a quick side note about Alt-Az setup. When you already have your mount mechanically set to the high gear pitch angle and dialed up to 90 degrees, your next step is to switch the software to the Alt-Az mode, and to do that, proceed as I already described. Hold down the bottom button on the AM5 hand controller and then turn on the mount. After that second beep, you can release the bottom button, but then hold it back down again for another 3 seconds or so. This will automatically send the declination axis to home position for Alt-Az. Now, when you open the AM5 application on your smartphone, it will already be in the Alt-Az configuration and ready to use. Before I put this telescope on the AM5 mount, let me tell you a little bit about my accessory configuration here. If you're like me, you probably have your telescope already set up for use in the equatorial mode, which starts in this position here. So usually what you're doing is putting any kind of accessories positioned on top. Now, this is very suitable for astrophotography. It works fine. As it's tracking objects across the sky, it moves in many different positions, but where those accessories are doesn't really matter because it's all automated. Now, I'm using this stock ring configuration here from SVBony that came with this 80 ED telescope. And you can see I'm also using this accessory plate that I mounted here. This plate comes from a company called 3D Astro, and it's made specifically for this telescope. It's very convenient, and it has allowed me to put a number of mini Vixen clamps up here, one for my guide scope, one for my ASIAIR, and I also use a laser pointer. And it works very well. It's very stable. I'm also using a Losmandy plate on the bottom because I feel it's just a little bit more stable and secure held into the mount. Now, if we want to use this in Alt-Az mode, well, that presents a problem because as you can see in Alt-Az mode, the starting point is like this. It's mounted on the AM5 mount from the side. Now that means all of our accessories are going to be hanging off the front here, which is inconvenient and perhaps less stable. So it's ideal to mount them 90 degrees from the mounting plate here basically on the top, but there's no way to do that with these ring clamps. In fact, most telescope manufacturers have ring clamps that are really only suitable for EQ mode, and that kind of bothers me. Maybe the only exception is Sharpstar ASIAIR, which have some excellent ring clamps that are multi-purpose and have got mounting holes basically all around. Well, because of that, and because I want to use multiple accessories tonight when I'm doing my viewing, I created a new ring setup, and this contraption I assembled from bits and pieces. And let me tell you a little bit about this now. To begin with, I bought a ring set off of AliExpress, and these are made by a company called Astrohop. They're a very sturdy metal construction, and it's six-sided. And on each of those sides, there's at least one drilled threaded hole, 1/4 inch hole for mounting accessories. The internal diameter is exactly 90 millimeters, which is a perfect match for the 80 ED telescope from SVBony. I attached 2 Vixen bars here and a total of 4 clamps. So yes, I'm going to be using 4 accessories tonight when I do my visual astronomy. Sounds like an overkill, but you'll see how functional it is when I show you some video from tonight. On the side here, I mounted a Losmandy plate, and you can see when that's going to be mounted in this direction that most of these accessories are going to be positioned on top and making it very convenient for doing some visual observations. And here is how it looks when you put it on the AM5 mount. Most importantly, make sure it's on the proper side. When you're looking at the mount, that'll be on the left-hand side facing in that direction. It should be perfectly clear because on the mounting plate, there's actually a depiction of the telescope. As you can see here, in this mounting position, the focus knobs are parallel to the ground, and of course the eyepiece is pointed straight up. And no matter which way that you move this mount, in the azimuth mode, or in the altitude mode, or any which way, that it's always going to remain in that position, and you'll always have access to the eyepiece to be looking at your object. This is the beauty of the Alt-az mode. It works on an XY coordinate system. If I want to go back to home, I simply hold down that bottom button for about 3 seconds, and that'll put it back into the home position. And you can see all of my accessories here are going to remain on top when I'm doing visual observations. In this depiction, what the observer needs to do for the setup is to orient the mount with the telescope pointed directly to the true north, or as close as possible. And the tripod and the mount must be absolutely level. This is just a simple XY coordinate system that is oriented to the horizon and applicable anywhere on Earth. But you must be sure that your latitude and longitude location is programmed into the AM5 mount and/or ASIAIR software to provide accurate tracking. There are bubble levels on the base of the AM5 mount that can help assure good leveling of the mount, but you should also independently check the top surface of the AM5 housing to be certain that you've tightened the gear pitch angle at exactly vertical, 90 degrees. You must do this before the next alignment step. Unlike the equatorial mode, there is no polar alignment application for setting up your telescope in Alt-az. You don't need that level of accuracy. And you don't use guiding either. But let me show you now how to get a reasonably good north alignment. So first, be sure your mount is parked in the home position, and then orient it as best you can with respect to Polaris in the sky. And then we're going to raise the level of the telescope using the vertical movement only with the hand controller. Do not adjust it at all in the azimuth left and right direction. In order to get Polaris, and if you need to adjust the azimuth direction, then use these knobs at the base of the AM5 mount in order to move it in the azimuth direction left and right. And if you can get Polaris then in the center of your field of view, you now have your mount adjusted quite accurately to north. Now in the field tonight, I'm going to have a laser pointer mounted to the side here, and that's going to be aligned with my OTA. And so I'll simply use the laser to do my alignment with Polaris. So the accuracy of the alignment comes with being sure that your mount and your tripod are as level as possible with respect to the horizon, and that the OTA is aligned in the azimuth mode with Polaris. And if you can do that, you should get some good tracking for a long period of time. You'll be able to see your celestial object in your field of view. So I believe we're all set now, and I'm looking forward tonight to heading out to the field to do some visual astronomy under these beautiful clear skies. Hi, it's me again. One more thing. If I was going to do visual astronomy here in my backyard, I would simply pick this up, transport it over there to the grass, align it to north, and I'd be all set. But the fact is, I'm not going to do that here tonight. I want to go to a park where I got a much better view of the sky. So I'm going to have to disassemble this and put the mount back in the case. But it only fits in the case if it's in the equatorial mode, in the home position. So we're going to have to reset this back to the equatorial mode, put it in the home position, adjust the angle, and then put it here in the case where it fits properly in order to transport it and to take it out to the park. Now I have to set it up in the park. I'll have to go back to the Alt-az mode and use it that night. And when I'm done, reset it back to the equatorial mode, put that back in the home position, adjust the angle, put it in the case, and then I can bring it home. So it's a bit of a hassle, but unfortunately, there's no way around it. Let me start by welcoming you to Kawawafuji Park here. I've described this lookout area previously. We're about 20 meters above the surrounding ground here, and it's a great place to do astrophotography at night. I have 360-degree view all the way to the horizon. Behind me over my left shoulder here is the city of Yokohama, the downtown area in the background. So here's my visual astronomy setup. Starting off with the SVBony SV503 80 ED telescope. And aligned with that OTA, I have this laser pointer that when I turn this on, you can see that going up into the sky, it's actually close to the star Polaris. And since this mount is in its home position in the Alt-az mode, I think I'm pretty well aligned on azimuth right now. In addition, over here on this side, I have a 200 millimeter focal length, 50 millimeter aperture finder scope with a prism diagonal. And on that, I have the Paradigm 25 millimeter lens, the eyepiece. That'll give me an 8x sort of wide field finder look at the sky. And here on the business end, I have a mirror diagonal, and my new Baader Morpheus 12.5 millimeter eyepiece, which this is the first night that I'm using it. That's sitting on top of an Explore Scientific 3x focal extender. So I think the total is going to be around 1500 and something millimeter focal length in this configuration. So that'll give me a nice view of the planets. I also have set up here to do some plate solving and to make it easy to get to targets, especially ones that are very difficult to see. I'm using the ASIAIR connected with a small telescope here, which is the ASIAIR 135 millimeter, and on the end of that is the ASI 678 MC planetary camera. So this is actually doing the photography for me. The ASI is helping me do the plate solving and going directly to targets. And all of these things, this scope, that scope, the OTA, and the laser finder are as well aligned as I can possibly get them. Currently, we're in the home position, as I mentioned earlier, or actually I elevated it to take a look at Polaris. And taking a photograph of Polaris, I actually focused on that earlier. I have a tiny little batten-off mask that I bought from 3D Astro, and actually it works very well at focusing these tiny little finder scopes and this 135 millimeter scope from ASIAIR. So I know I'm in good focus, and I just took a picture there. Everything looks good, and I'm going to go to Jupiter now, and we'll see how this works. So I'm not using the go-to finding function associated with the AM5 mount. That does exist. It does have a go-to function, but you know, these go-to functions with the mounts that are not guided by plate solving are nowhere near as accurate. You can see here it's making fine adjustments now to get Jupiter right in the middle of the field of view. Validate centered or not, detected 211 stars, target is centered. Let's take a look. Right in the middle of the finder scope. Beautiful, right in the middle of my Morpheus Baader eyepiece. And there's the picture of Jupiter right there in the center of my ASIAIR 135 telescope that's driving the plate solving. So we're all set here, and I'm gonna do some star hopping and get to look at a lot of different things without having the hassle of actually trying to find them in a sky like this, because at Bortle 7, Bortle 8, you're not seeing much more than very bright stars, and that's about it. So it oftentimes gets quite difficult in order to navigate by eye and to try to find things manually.
The next few video images are of Jupiter and Saturn. These are images taken through the Baader Morpheus eyepiece using my iPhone 11 camera. I did this just to give you a flavor of what can be observed on an average night of mediocre seeing. It is a pretty good depiction of the visual image quality, showing the two prominent cloud belts on Jupiter and at least one close moon when you adjust the exposure or gain to overexpose the image. You can also see there is a bit of chromatic aberration apparent at this high magnification of 144 times with an 80mm aperture doublet scope. I must say that I never really see any chromatic aberration of stars or other objects during astrophotography or visual observations at lower powers, but I am not an experienced astrophotographer, and I have frankly never even looked through a good triplet refractor. So perhaps my assessment for imperfections is a bit more generous than experienced amateurs with high-end equipment. but I just want to say that I'm extremely satisfied with the SVBony SV503 80 ED telescope in its performance under routine astrophotography use. If I had an extra $2,000 burning a hole in my pocket, well, of course I would buy a fancy triplet scope, but it just doesn't seem worth it to me at this point. Just saying. By the way, if you watch the Jupiter image closely, I believe you can see a dark spot in the lower left-hand side. Although I have not verified it, I think this is a shadow of a moon making a transit in front of Jupiter. Interestingly, Saturn, which is also a gas giant planet, appears significantly smaller than Jupiter. But did you know that from Earth, the distance to Saturn is nearly twice that of Jupiter on average? It is 628 million kilometers to Jupiter and nearly 1.3 billion kilometers to Saturn. I think that is a fun fact to explain why Saturn appears so much smaller in the field of view of a telescope. Visually, one can often see the 4 biggest moons of Jupiter, even with a small telescope, but the moons of Saturn are much more challenging to observe. Still, the view of Saturn with this Morpheus eyepiece at the 144x magnification is quite impressive, and always draws an exclamation from first-time viewers who seem to think that actually seeing the rings of Saturn was not possible by hobbyist astronomers. It is certainly very impressive, thanks to SVBony, Astronomics, Explore Scientific, and Baader, who each contribute to this visual image integrity.
So at the moment, I'm looking at a globular cluster, which is M2. I found it, of course, using my go-to function here in the plate solving. And it looks quite bright, of course, in the photograph, but, you know, under these Bortle class 7 and 8 skies, I can actually see it, though. It's a faint smudge, which is really the first time I've ever looked at a globular cluster before. So it's definitely there. And averting your eyes to the side, you can see it a little bit better. So this is really working very well as far as finding specific targets in the sky. Now, Jupiter and Saturn were marvelous when I used the Barlow lens, and now I've taken the Barlow out, and I'm going to see if I can find some other interesting objects to observe. M2 is rising toward the zenith and in the darkest part of the sky, so I thought I would try that one first. So this Morpheus, Baader Morpheus eyepiece that I bought here actually is quite nice. It's the first kind of really premium eyepiece that I've ever purchased. I've been using the Paradigm set of eyepieces that I purchased from Astronomics, and they're quite nice. They're about $65 a piece when I bought them 2 years ago, and they do the job just fine. They don't quite have the eye relief that this thing has, so this has got like a 20 millimeter eye relief, which is really amazing. So I can actually use my glasses, although I usually don't like using them. In addition, the contrast in this eyepiece is definitely better than the Paradigms. And the other thing is there's less sort of light around the edges. It's a more uniform black, high contrast darkness across the entire field of view. I have tried to look at star-rich areas with this, and it's really nice in that you do see all the way up to the edge. The stars look beautiful all the way up to the edge. With the Paradigm, it sort of fades out a little bit or distorts a little bit at the edge, but definitely not bad. This is just an upgrade from that. So at $300, is it worth 5 times the price? Well, I think to have one good one in your collection, especially to use when looking at the planets, I think that's important. So I'm glad that I bought it, but I probably will not buy another one. I bought the right focal length so that in combination with the 3x Barlow, I get a really good view of the planets. And they come through amazingly clear. So actually you can see the banding patterns on Jupiter more clear than when you're using the Paradigm eyepieces. So it does have that also advantage. So I think on all these different features, it's slightly better, slightly better, slightly better, and consequently, it's a better performing eyepiece for sure, hence the price. Now, of course, we're not doing any guiding. This is not astrophotography. This is just using plate solving to find the target and then let the mount actually do the tracking. It's now been, 10 minutes or so, and it's barely moved off the center. So it's quite well aligned for the Alt-az tracking. Okay, I'm going to find another target.
So by now, you're probably asking yourself, well, what the hell is this? Well, this is Kawawafuji Park. You never know. At all times of the day or night, people visit this small summit to rise above the trees and rooftops and spend some time secluded with views in all directions. These are a group of high school boys who came out to smoke cigarettes, listen to their music, and enjoy their independence. I see this quite often. Sometimes just girls, sometimes boys, and sometimes a mixed group or even couples. Often they are curious about the instrumentation, but these guys were not at all. We chatted a bit, but mostly did not interact. I found them amusing and entertaining, so I secretly captured a bit of their antics as I engaged in my visual astro exploration. One of my first targets was an open star cluster called M29. I took a 10-second photo in my Finder plate solving setup. You can see that image with the ASIAIR annotation shown in this first photo. This second photo is the full image taken by the ASI 678MC Planetary camera. Being such a small cluster of stars, I probably would have never found it if I was searching by eye navigation manually. The power of the ASI plate solving technology made it quite easy. And on this last image is a representation of approximately what I saw through my telescope using the Baader Morpheus 12.5mm eyepiece with the SVBony 80 ED telescope. This is about a 45x magnification. The image was clearly larger than the Finder scope image. It was a nice sight. After that, I slewed to the M52 star cluster. This is located near to the Bubble Nebula in the northern skies, but it was frankly difficult to see. Another target was the M92 globular cluster. It has a visual magnitude of 6.4, very similar to M2, which I observed earlier. Under these bright Yokohama skies, I think magnitude 6 is about the limit that can be seen for globular clusters with an 80mm aperture. It was just barely visible as a faint smudge of light to the human eye. I also went to NGC 869, the double-double cluster. Its image in the Finder scope can be seen here. The larger stars in this cluster were quite visible to the human eye in the telescope, but the many smaller stars were not. So that made it a little difficult to identify the edge of one cluster and the beginning of another. I stared at this for several minutes, trying to identify the boundaries. The night moved on, and so did my exploration of the sky. I looked at several more objects, including double stars. There was no moon that night.
Well, I guess that's it for tonight. I think I've done enough visual astronomy this evening using my fancy contraption here with all of these accessories. The ASIAIR with the With the small finder scope I have here, this ASIAIR scope was great for zeroing in on targets that I really wanted to find and to look at. This new Baader Morpheus eyepiece I really like. I think it's great to have this in my arsenal. The 12.5 millimeter version of it is probably perfect for this setup. Gives some great views. I saw some globular clusters, but just barely in Bortle 7, Bortle 8 class skies. It's kind of hard to see them, even at magnitude 5 or 6. And looked at some double stars and some asterisms, the planets, of course, the double-double cluster. I had a good time sort of scanning the skies. Using my laser here, I actually zipped around the skies a few times and looked at various objects. The AM5 mount worked great in this Alt-az mode, and I like the application here where you can find objects in their catalog here, and it displays those objects and where they are in the sky in terms of the altitude. So the blue dots on these graphs and the red line corresponds to the trajectory across the sky. So that's important because it allows me to focus on only the objects that are going to be high in the sky, and I can identify which of those are by looking at this application.
Interestingly, between the time I made this video and the processing and publication, ZWO came out with a new firmware release for the ASIAIR application. In that new software update is a further upgrade to the target search and information display capabilities. Now, there is not only the ability to see potential target information, but to also filter the information to select for targets using a few different selection criteria. For example, all targets visible above 55 degrees of altitude that are found there between 8 p.m. and midnight, or targets found only in the southern sky, or a combination of all that. This makes it even more convenient to not only find solar system or deep sky objects, but also to sort the information and select them for observation. Once you have found what you want, all one has to do is just press Go To on the screen, and the rest is automatic, like usual.
So overall, it was good. I think that having a setup like this with all these convenient features actually makes me want to come out here more often and do some more visual and makes it very easy and quick to show people things. And it's kind of fun for me to be able to share with them my experience here and have them look through the telescope. For almost all of them, it's the first time they've ever gazed at any celestial object in a telescope in real time. So it's kind of fun to let them have that experience. So thank you again for joining me at Astrophotography Japan. I hope you enjoyed it. Please come and watch another video in the future. Otsukare-sama, oyasumi nasai.